Hey guys, it's Robbie from Motec. Today we're going to take a look at the Gen 5 LT1 and the Gen 4 6.2 engine. This is a Gen 4 6.2 L94, which is one of the last of the generation of the Gen 4 engines. This is a LT1 with an 8L90. It's a 2017 engine. We're going to look at both engines and the advantages and disadvantages of each. Alright guys, we got a lot of ground to cover, so let's get going on this Generation 4 6.2 L94 engine. There's basically three 6.2 Generation 4 engines we're going to talk about. One is the L92, then the L9H, then the L94. This is an L94. They're essentially all the same engine except for some options. All these engines are aluminum blocks. This L94 has air fuel management. You can tell if your engine has air fuel management if it has this 5-pin connector on the lifter manifold assembly. If it does not, you most likely have a L9H or an L92. You ask, what's the difference between the L9H and the L92? The L9H came out in 2009, and it used the new fuel rail and injectors. These are flex fuel injectors. The L92 did not use the flex fuel injectors. So GM actually had a different intake manifold. And if you look at this MAP sensor, MAP, manifold absolute pressure, that's also different in the L92. And it's one of the reasons you can't mix and match the L92 operating system with the later operating systems. So let's look at the architecture of this engine. It's pretty much been the same for about 10 years. And this is a strong engine, and this is going to apply to the LT also, so let's take a look down here. By the way, these are our easy mounts getting ready to drop in to a chassis. This engine has a skirted block, which means basically the block extends down past the crankshaft and it's cross-bolted. Back in the day we used to spend a lot of money to get custom blocks like this, but the LSs and the LTs have this right out of the box. These manifolds work excellent. These happen to be Trailblazer. Trailblazer manifolds have a 3-bolt flange, and you can see they're cast pretty much like a header. We've tried shorty headers and we've found very little if no advantage. The headers do tend to put out more heat and noise. We've tried mid-length and long tube. Long tube is really the only ones that give you some extra horsepower. Make sure you run the heat shields on these. Keeps the heat down in the engine compartment. Most of these LS engines have the displacement cast into the back of the block. You can see down here this is a 6.2 liter. So you know this is aluminum. You know it's a 6.2, not a 5.3. You know it has air fuel management. And you know it has the flex fuel injectors. So you know this is an L94. This engine was made basically from about 2010 to 2014. It was put in all the half-ton SUV trucks like Escalades, Denali's, Silverados. This engine does have our billet accessory drive, so we're running a JK alternator, power steering pump, and AC compressor. We have our coolant reservoir pre-mounted. These hoses, one goes to the radiator, and that's the one that is cut off at the bottom of the bottle. The one that sticks up is your overflow, so as the coolant level goes up, it overflows into that. This is our air conditioning riser. This is going to go directly to your current AC line. The advantage of that is you can use your factory AC lines. If you ever blow a hose, you just go to the dealer and buy a new one. These engines, for the most part, are pretty simple. We've got our coolant temp sensor down here, MAP sensor. Our MAP sensor would be the air intake tube up here. This is our throttle position sensors, and I say that plural because we got 2 sensors in here. This is our steam port. You will notice we're using coolant line, not vacuum line. This is under pressure. Basically, these engines are reverse flow, so as the water comes up, steam pockets build up at the top of these heads. Now this engine has a spreader tube between the heads and then this one port coming up. And I think it's time to step over and let's take a look at this LT, because that's what this video is really about. This LT has a lot of different technology compared to the Gen 4, and you can see that they simply built the steam port right into the thermostat housing. I don't know what they did in the LT cooling system, but I can tell you it works great. These engines are high compression and they seem to run cooler than the Hemis and the LSs. Can't tell you why yet, I haven't studied it, but that's my experience. So getting back to the LS, let's look at some of our sensors. This is our purge valve. Basically you have full intake manifold vacuum coming in here. This is going to go back to our fuel tank, and you can see we've already put the hose on. This is our fuel line that we supply in the kit. Plug and play. You're going to go from your fuel rail right down to the fuel tank. This is our universal coolant bottle bracket, by the way. We've noticed that these bottles have different offsets, so we racetrack these, and you can slot them up and down. You want to run this bottle as high as you can get it so it doesn't hit the hood. This is a factory JK alternator, and the beauty of that is it plugs into the original connectors, and you have smart charging right through the tip like you did from the factory. This is our oil pressure sensor. This is a 3-wire sensor. This isn't a switch. These are our fuel injectors, as you know, and you might or might not know, but you can twist these so that you can get the wiring in the best position. Let's drop down to the bottom here. We've got our knock sensor, and again, you can loosen this bolt and twist this wherever you want. Make sure you run that cable away from the exhaust. We've got our passenger side knock sensor. This is our crankshaft position sensor. Try to put this sensor in before you put the starter motor in. It makes your life a lot easier. These easy mounts are adjustable on all 3 axes. All right, let's go to the front of the engine because there's a lot of stuff happening here. This happens to be a truck drive. We also offer the LS3 L99 drive. This is a truck water pump. You can tell because it has the threaded nose on it. We've been making this setup for going on 9 years. The difference now from the early days is these are a billet, no alignment. We're using a factory JK tensioner. If we drop down here, you're going to see the sub harness. This sub harness is going to do 2 things. 1 is your cam position sensor, and 2 is your cam phasor. This engine has, and this is important, this has discrete variable valve timing. What that means is the cam is basically in 2 positions, parked and open. When the engine is at low RPM, it's advanced. When the engine revs up and it gets to a predetermined RPM, let's say 3,000 or 4,000 RPM, the cam phases, it retards, and it gives you some more top-end power by building that cylinder pressure up. One of the big advantages of the LT over the LS is continuous variable valve timing. So if we come over here and look at this LT, we have a similar harness, but now we have 3 connections. Again, this is our cam sensor, this is our cam phasor, and this is a dual stage oil pump. And we'll talk about that in a second. But let's talk about this phasor for a second. This phasor is not discrete, this is continuous. What that means is we can move that cam and put it wherever we want. By doing that, we have much better control on cylinder pressure. And this is one of the reasons we can run high compression in this engine. We can run high compression in this engine because of direct injection, and we'll get to that. But also we can vary the combustion chamber pressure by phasing this cam partially. We don't have to have it in one position or the other. This is a big advantage over the earlier engine. This is a dual stage oil pump. This has been pretty common over the last few years. Manufacturers are always looking for a way to get a little bit more efficiency. By going to a dual stage oil pump, you can have less friction on the engine when you don't need that high oil pressure. The other thing about this dual stage oil pump is this engine does have air fuel management. Early in the Gen 4 days, this lifter manifold assembly basically uses oil pressure to displace pins inside the lifters, which then turn these cylinders into air spring. One of the issues with DOD or AFM in the early days was if you had a sub-0 day temperature and you fired your engine up and that oil pressure built up too high, it could damage the lifters by overpressurizing them. So what GM did is they ended up installing another oil pressure relief valve inside the oil pan. So even on a cold day, if you fired that engine up, not only would the primary oil pressure relief valve kick in, but you also had this secondary one that would keep you from damaging the lifters. So GM pretty much nailed these engines by 2009, 2010. And that's the same thing that we saw in the LTs from 16 and 17. Some of the early ones had some issues, but the later motors seem to have corrected that. Let's finish up on this Gen 4 engine. Here we have an auxiliary port for vacuum that could be used for powering accessories inside the vehicle, whatever. Some of the 6 liters and others had not only a map sensor, but a baro sensor on the side. A barometric sensor would allow you to read atmospheric pressure. That really helped when you were changing altitude rapidly. One of the things about speed density systems is they use airflow lookup tables, and Chrysler's done this for years. The problem with that, if you have sudden rapid altitude changes or barometric pressure changes, it's just not as accurate because you don't have an actual airflow meter like a mass airflow sensor, and you don't have a baro sensor. So in some cases it was recommended if you change altitude rapidly to shut the car off, let the baro reset. This can actually act as a barometer when the key is turned on before you fire the engine up. And then that gives the operating system more information to act properly. This is a tap-off for our PCV valve. For many years now, GM has been putting the PCV valves inside the valve cover. Make sure you run that. Basically, PCV, or positive crankcase ventilation systems, scavenge the blow-by from the pistons and other contaminants, and they basically get sucked in here And this is our aspirator tube, which has to go between the throttle body and the MAF sensor. And the reason you want to do that is the MAF sensor is actually calibrated to take this airflow into account. So if you were to put this on the outside of the MAF sensor, you could have a problem. Here we have our lower outlet, which is interesting because we have our thermostat inside. Normally you're used to seeing a thermostat in the top on the old small blocks. These are our heater hose outlets. This is a drop bracket for the transmission cooler lines. They come across and then they'll end up about here and then drop under the cross member and go up to the transmission cooler. For years now, GM has used these stainless steel shim exhaust manifold gaskets, and I really like them. Several years ago, GM started to cut. This one has not been cut. You can see they partially cut it, but they started to cut these because as the manifold would expand and contract, that would take up and not warp the manifold. So now let's take a good hard look at this LT, because this is the future. This engine has a lot of technology. This engine is a powerhouse. This engine has a lot of potential. This happens to be an LT1, so it only has 2 belts. We get our air compressor and our main belt. If this was a truck motor like an L83 or an L86, you'd see a third set of grooves in the back, and that would drive a vacuum pump. I really like that setup because basically with a vacuum pump, even at low RPM, you have full braking available to you. As most of you know, the Penstars ran an auxiliary vacuum pump in the bumper, and they used a brake booster pressure sensor. So when the brake vacuum dropped low, that pump would turn on and give you more vacuum for your brake. Well, with the L86 and L83, if that vacuum pump's turning, you've got vacuum. On the LT1, they did put a brake booster fitting in the back of the intake so you don't have to run the vacuum pump. So we have to start somewhere, and this engine's got a lot of technology in it. It's one of the reasons this engine has so much power and so much torque. I say they run halfway to a diesel because when you fire these up, they have an internal mechanical fuel pump that builds the pressure up to a couple of 1,000 pounds, and that's for the direct injectors. Now the injectors on these engines put the fuel directly into the combustion chamber, and there's a lot of advantages to that. There's also some disadvantages, but I think GM has that all sorted out. When you spray the fuel on the backside of the intake valve, it tends to keep it clean. Manufacturers have fought carbon on the backside of the valves and blow-by, and some say that direct injected motors need catch cans. Now GM did run a catch can in the LT1, but they did not in the truck engines for whatever reason. I can say we've been running these engines now for a couple of years. I did have one customer in Canada drive from Winnipeg all the way to Baja and back to Canada, and he said he caught about an ounce of oil in his catch can. So I don't think that's terribly a lot. It's optional whether you want to run a catch can or not. Speaking of these direct injectors, by putting that fuel into the chamber, we have efficiencies that we could not see before. We can raise the compression. Combine that with the continuous variable valve timing, and what that means is this engine is 11.5 to 1 compression. We've run the L86s on regular gas. What we have here is control of cylinder pressure. When we can control cylinder pressure, that means a lot. There's a lot of things slave to cylinder pressure. One would be pre-ignition. Now in the old days, we used to run EGR valves, exhaust gas recirculation valves. In fact, let me show you one. This is an engine straight out of a 2018 JL. And this engine has an EGR valve up here. This EGR valve complicates a lot of things. Here we have an EGS, an exhaust gas sensor or a temp sensor. Here we have a water cooler for the EGR system. We've got all these hoses. Basically what happens is we're taking, and these engines don't really run exhaust manifolds. They take this aluminum head and put a converter right on the outside of it. I believe that's one of the reasons the early Penstars had death tick. In fact, these converters can build up so much heat. There's all sorts of things that can happen. You can see the heat proofing here. This engine did happen to blow a head gasket at 500 miles, and you can see the coolant here. So I'm not a real big fan of the design of the Penstar engine, but what we got here is basically all this EGR, exhaust gas recirculation. What happens is we're taking inert gas from the exhaust and we're putting it into the intake. And you say, well, why would you want to do that? Well, when you run high cylinder pressure, especially in a high compression engine, oxygen and nitrogen melt together at about 2,500 degrees. That forms a bad gas called NOx, N-O-X, X being the number of oxygen atoms melted to the nitrogen atom. So, we don't want to form NOx. By taking inert gas and putting it in the chamber, we can cool the chamber down and prevent the formation of NOx. Some people also call this valve the anti-knock valve, because in an engine designed for an EGR valve, if you take the EGR valve off, you might build up that cylinder pressure and get pre-ignition. The LT and the LS have done away with the EGR valve. However, if you look at an operating system for an LS or an LT engine, you'll see an EGR monitor for emissions. Why is that? Well, we can use variable valve timing to control cylinder pressure. We can lower the cylinder pressure and reduce the formation of NOx. Also the valve strategy, how the valves open and close. GM has done some really smart engineering and eliminated the Egr valves in these engines, and it really cleans them up. You'll also notice that GM is running real manifolds. Now this LT1 does happen to be running stainless welded headers, but most of the production LT1s and truck engines come with cast iron headers, which in my opinion are just fine. And you can see here that they did cut this manifold to relieve it for stress. Here we have a breather, our traditional ignition coils, and you got to think of these motors almost as 8 individual single cylinder motors, because the operating system in these can control each cylinder individually. We can control the fuel and the spark timing independent from the other cylinders. So it's almost like 8 individual cylinders, although of course not quite, because they are slaved together by common crankshaft and camshaft. You can see our easy engine mounts, and you'll notice that there's no modifications to the brake lines or wiring for the ABS. You notice that there's no interferences, even with the upper control arm, which normally would smack a compressor in this area. There's no problem with the Gen 5. This is a spreader tube that we use to get the coolant from this side of the engine to this side of the engine, because it's difficult to run a radiator with an outlet here because of the power steering gear. This does happen to have a truck accessory drive on it. We also support the Camaro accessory drive, and you can see we have plenty of clearance. Here's our easy mount on this side. We're running a factory GM accessory drive except for our add-on power steering mount. The LTs did not come with power steering pumps. They use electric steering like the JL. So we have our add-on power steering pump, and it's a relatively clean setup that is issue-free. You can run, as you can see, PSC with our bracket, and you shouldn't have any issues. So let's go up here and look at some of these connections. Here is the connector for the coolant temp sensor, oil pressure sensor, and air fuel management. Now, air fuel management in these engines is a lot more sophisticated than it used to be in the old days. We have a throttle body. We have electronic throttle controller, ETC. When the Cadillac 468s came out back in the 80s, they didn't have that technology, nor the computer power that we have today. So when AFM kicks in or out, it doesn't just kick in or out, it stages one cylinder at a time to bring it in and kick it out smoothly. And it also compensates for the throttle body based on the engine torque output. So you as a driver are minimally impacted by going between 4 and 8 cylinders or 8 to 4 cylinders. Here's our PCV on the LT engine. They kept it tight. They didn't go back into the valve cover. Here's our purge valve. You notice that it's mounted directly into the intake, making it a little bit cleaner. A lot of stuff going on back here. You can see our intake isolator, engine trim cover, transmission and transfer case vent line. Here we have our low pressure fuel sensor. Remember, this runs a low pressure and a high pressure pump. Low pressure being the original pump in the tank, which just gets the fuel up to the high pressure pump. This is our injectors and our low pressure feed. This is our injectors and our high pressure feed on this side. These connectors, and this is a warning, are identical. You can swap these and your engine's not going to run. So make sure that you get these plugged in properly. This is an extremely compact engine for what it does. And the LT4 is not much taller, and it's got a blower on it with over 600 horsepower. And yes, we are going to do some LT4 builds. If you look how compact this engine is, it really fits the JK perfectly. We have plenty of room for our steering. We have no interference. These are full-size hydraulic engine mounts. Moving on, here's our fuel inlet from the JK pump. This is our MAP sensor. And again, GM runs both a MAP sensor and an airflow meter. And I want to say something about the airflow meter in these LTs. Here's an airflow sensor in an LT. And you can see how many wires this has. This not only has an airflow or a mass airflow sensor in it, it also has intake air temp sensor and a humidity sensor. What this does is this allows this sensor to give a lot more information to the computer than before. Now, if you're running a speed density system like most of the Chryslers, you don't have this information. You don't have humidity sensors. You don't have actual airflow calculations. This can be invaluable. If you get into high humid conditions, you change altitude rapidly, this sensor can make the drivability, in my opinion, smoother and better than without it. Problem with mass airflow sensors is if there is a problem, they will react to it, even the smallest problem like an air leak, and then your drivability drops down. So the speed density system, while it may be simpler, in my opinion is not as efficient or as drivable as a proper airflow operating system that uses actual airflow calculations rather than calculated. For whatever reason, GM did decide to move the knock sensors back on the LT. Maybe they pick up engine knock better. And then here's our crankshaft position sensor, just like in the Gen 4, which reads directly off of the crankshaft rather than the flywheel like the early JK. Being internal in the engine means you can basically drive through water, underwater, and you're not going to affect that crankshaft signal. We will be installing a new GM alternator, and yes, this GM alternator will be smart charging off the GM computer. In fact, almost everything is going to be controlled by the GM L92 computer. This is a variable displacement compressor that will be controlled by the GM computer. AC condenser pressure for fan control will be controlled by the GM computer. AC idle bump, which means when this compressor engages and pulls the engine down, that will be controlled by the GM computer. And of course the smart charging will also be controlled by the GM computer. So we have a low pressure fuel supply coming into the rail, which then goes under the intake to a high pressure pump, which mechanically turns that into thousands of PSI and injects it directly into the combustion chamber. We're gaining a lot of efficiency there, as well as through this continuous variable valve timing. When you put these technologies together, what you get is instant torque. I'm talking torque off the line that I haven't experienced before in gas motors. L86s can have near 400 foot-pounds of torque just off idle. That's more torque than the engine that came in this vehicle had anywhere in its power band. This is what it looks like under the manifold of an LT engine. You can see our high pressure fuel components. This vehicle just got an L94 swap. I do believe this vehicle is going to be going to California at some point. You can see how well everything lays out. Our Jeep alternator goes right back where it was. Our Jeep air compressor goes right back where it was. In fact, we're using the stock air conditioning lines with our riser block as I showed you. Our power steering pump goes right back where it was. So our power steering lines are OE. You don't have to go and have custom lines made. This vehicle is getting PSC steering, and you can see that the PSC pump fits in our billet bracket. So these power steering lines and these air conditioning lines are OE Chrysler. This vehicle is also getting an LT1 engine, and you will notice that we do not open up the power steering system nor the brake system. We leave this closed for the swap. We essentially put the motor in, we drop them right into these mounts, and then put these components right back where they came from. If you look hard, you can see that we relocated the evap canister to the back, and that's really the only other modification. You can more clearly see here how we do not have to modify these original mounts. These mounts, electronics, and hydraulics all stay untouched. Now this has been changed because he's added some longer suspension on this, and he had to disconnect this from the chassis to give the ABS sensor more room. So that's a quick overview of the LT engine. This is a phenomenal engine and is going to be part of the engine swap world for the next 5 or 10 years, in my opinion. And when you combine this engine with an 8-speed transmission that can take the power, and yes, the 8L90 can handle over 700 foot-pounds of torque, it's hard to beat in a JK. This Jeep has an L86 in it, which is very similar to the LT1. I wanted you guys to take a Sorry, we're outside on Nellis Air Force Base. Even with all this weight, the L86 pulls this JK with ease. This is something you really couldn't do with a Hemi or an LS or a supercharger, because the inherent torque, the direct injection, the high compression, the 4.6 low first gear all come together and make this vehicle feel light, even though it's not.